Hello, my name is Joffrey Wilson, Strategy and Market Development Director at Mortenson. I did go through some training on presentations, and rule number one was don't use a PowerPoint. So I've broken one rule already. And the second rule was don't start off with a slide that says who you are, and I'm going to do that too, but there's a reason for it. When I say the name Mortenson, people don't know who Mortenson is necessarily, so I wanted to give you a little bit of background in terms of what the company does. It'll make a lot more sense as I go through the presentation in terms of some of the work that we do. So this slide highlights a little bit of the history of Mortenson. We've been around for about 60 years. It's a private family-owned firm. The size is about $5 billion and started in commercial construction. The commercial construction business focuses on designing and building projects like stadiums. So the new Raiders Stadium in Las Vegas, that's something that we're building right now, or a data center for Facebook, or higher education buildings and healthcare facilities. The company moved into energy, and that has become a large portion of the business today. So first starting in renewables with wind and solar, so large utility scale wind farms and solar farms all around the country. We have done the engineering and built much of what you'll see in the marketplace today. And once we had enough of a presence in renewable energy, we determined there was ability to build a high voltage transmission business. So that's transmission lines and substations. And then determined that the world is actually starting to shift towards distributed energy resources. So what you see on the far right there, battery storage, the ability to store power when it's cheap and deploy it when it's expensive, and arbitrage and all these different services that batteries can provide. As the cost of battery storage continues to come down, we'll see a lot more capabilities deployed. And then moving into EV charging infrastructure. So as all these consumers start to move towards electric vehicles and fleets, there's infrastructure that's going to be needed. We'll talk about what that is today. And then finally, microgrids. So there's need for more resiliency or sustainability, and microgrids are one way you can achieve some of those goals. So I now want to talk a little bit about insights with respect to electric vehicles in general, and then we'll talk about some insights that we uncovered via a study that we conducted that I think you'll find interesting. So this slide very much aligns with what you saw in Eddie's slides a moment ago. So first, there's a lot of electric vehicles that are coming. You know, the graphic on the left paints that picture. And the why electrification is coming, it's really three things. In cases, there are cost savings. So in the cases of electric buses, you're paying a premium in the upfront in terms of going electric versus a diesel bus, but over the lifetime of the vehicle, there's potential for cost savings. The second reason is sustainability, so the ability to have a cleaner vehicle and perhaps a better experience. And in cases, the third thing applies, which is mandates. So in some cases, regulators are pushing towards more sustainable transportation. So those are some of the reasons why. And when you have all those electric vehicles, the graphic on the right points to the fact that we're going to need significant infrastructure. And the charging ports are one type of infrastructure that's going to be needed, but it's not the only type of infrastructure that's going to be needed. Which brings us to this next slide here. So when we say EV charging infrastructure, it's not only the ports or the charger itself. We also think about things like solar energy. There may need to be generation on site to support EV charging. We also think about things like distributed energy infrastructure. So perhaps there isn't enough capacity on site to support hundreds of chargers, and there may need to be upgrades that take place, transformers and switchgear. I have a data center up there as well. We didn't talk a lot about, with respect to the study, autonomous vehicles, but if they have to have connectivity and communication, data centers become part of this. So there are a lot of different infrastructure components that we don't typically think about, but investment in all of those areas listed here are going to be needed as we think about infrastructure to support all the vehicles that are coming. And fleet infrastructure for our company is very interesting because when you talk about fleets, large numbers of vehicles converting to electric at the same time, we think those can move the industry faster, so driving change in a quicker manner, but they're also interesting projects because then you start to think about more of the assets on the left side needed to support massive fleets that are actually starting to electrify. And Chris just talked about this a moment ago. This is a model we're starting to see a lot more of. You'll see it framed up as energy as a service or infrastructure as a service. In many cases, there are fleet owners with interest to electrify, but perhaps they're capitally constrained. So third parties will come in, and that's a financier who's willing to put up the capital and own and operate buses, batteries, or infrastructure. They'd hire an EPC, that stands for Engineering, Procurement, and Construction, a firm like Mortenson to design and build that infrastructure. The utility is a part of the equation and a key stakeholder because there's potential revenue streams that a utility will pay for that EV charging infrastructure. And at the end, you have a customer who's benefiting by the ability to have an electric fleet, to have electric charging infrastructure to support that fleet, and they're paying some fee, perhaps an operations fee or dollars per vehicle, dollars per kilowatt. They're paying for that service over time. And the question comes up in terms of why would a financier step in to actually own? Well, there's certainty with some customers in terms of bankability, if you talk about a transit authority or a city as an example. But in addition to that, they can take advantage of different revenue streams that the typical fleet owner can't take advantage of. So as an example, if a part of an infrastructure solution includes battery storage, some of those financiers have the ability to generate revenues from a utility with a battery, whereas your fleet owner in general can't do that. So that's just a little bit on one of the insights and one of the things we think we're going to see a lot more of in the marketplace. So I'm now going to shift to the actual study that we completed. I would encourage you, if your organization is at all thinking about electric vehicles and what might make sense for your organization from a vehicle standpoint, this this conference, the ACT Expo, is one of the best in the industry. It stands for the Advanced Clean Transportation Expo. It takes place once a year in Long Beach, and we've attended the last couple of years now. And every conference, just like this one that you're attending today, there's an app. So we decided to sponsor the app, and it enabled us to get access to all of the attendees and to conduct a survey. And that survey yielded 200 plus participants, and it generated some insights so that we could develop this study that you see here, Electric Vehicle Industry Trends. And I'll give you the information if you want to download the actual study itself, but I did want to spend some time going through some of the key insights that came from the study. So the first clear insight from the study is the fact that clean transportation is coming quickly. We tried to get the participants to communicate what percentage of their fleet is clean today versus what percentage of their fleet they anticipate is going to be clean soon. And they stated that 23% of their fleet was clean today, but within 5 years, up to 50% of their fleet was going to be clean. Now, clean does not only mean electric. It could be CNG, it could be hydrogen, it could be electric. But the clear message we took away from this is the fact that the fleets that are in the marketplace today, they're going to be shifting towards cleaner technologies in the future. Second key insight, the participants told us that electric is the best option. So we gave them different options in terms of which technology is considered the best, and electric was considered the best. 3 out of 5 respondents, in fact, said that electric was their preferred clean transportation type. This is a very important slide here. So it is not clear in the marketplace that cost savings are a potential. So 3 out of 4 fleet owners anticipated clean transportation providing slight reduction in cost. I think that really depends on the type of vehicle. And I don't have the graphic in this slide here, but there's a graphic that we have that highlights cost parity for different types of vehicles. And we're closest to cost parity when you talk about electric buses versus non-electric buses. And when you go to other types of vehicles, that gap in terms of cost parity is going to shift. But in the case of buses, we do have a fact down here on the bottom. USPRG Education Fund shows that there is significant savings over the lifetime. In this case, $400,000 over the lifetime of a bus when you go electric. Now, the barrier, again, we talked about this before, the barrier is the incremental dollars you have to pay to go electric in the upfront, but over time there's saving potential. And that gap, Chris alluded to this before, is about $250,000. So a diesel bus may cost about $500,000. To go to an electric bus, it's about $750,000. As that technology is deployed more, we anticipate that gap closing, but that's where it stands today. So there are barriers to electrification, and infrastructure was determined to be the #1 barrier to electrification. And you unpeel that a little bit. And actually, that was number one, regardless of the type of respondent. We had fleet owners, policymakers, and suppliers. So infrastructure across the board was considered the number one barrier to electrification. Once you peel that back a little bit, though, it means a lot of different things. So some of that means there isn't enough infrastructure in place. Range anxiety is another reason, and not knowing how much it's going to cost. There's a lot of things when you unpack why infrastructure is the number one reason there. So there's a lot more investment that's going to be needed in order to enable electrification. So we've talked a little bit about big picture-wise, what is electric vehicle charging infrastructure? Why are fleets thinking about electrification? And I want to shift gears a little bit, and I won't spend a ton of time here, but I want to talk about some of the complexities with respect to project implementation. And this applies to electric vehicle charging infrastructure and other types of projects. And I'd say that our company has unique experience in this space. So a couple examples here. Chase Center, which is where the Golden State Warriors are now playing, the most beautiful arena I've ever seen. And actually took Greg on a tour there, but there's a chandelier that's probably worth more than my house in that place. But anyhow, the complexity that applies when you're building a stadium in a dense metro area, some of it is how do you not disrupt the surrounding businesses? How do you make sure you're not doing construction work at 2 o'clock in the morning and disrupting the neighborhood, the permitting process? Those are just a few of the examples. Panasonic's US headquarters in Denver, Colorado. So they actually wanted to build their US headquarters, but it also is a solar plus storage microgrid. So a lot of different stakeholders were a part of that, including the utility, who saw it as a pilot. The utility there is Xcel Energy. On the bottom right, that's a data center for Facebook in Utah. That is a unique business, and the number of stakeholders that we have to assemble in order to get a data center put in place, they tend to be energy hogs and not always the most popular things for some stakeholders to bring in, but certainly needed because you want to use your cell phones and computers and all of the technologies that we all know and love. And then the top right, that is Chicago Transit Authority. They have started the process of electrifying their fleet, which I think is about 2,000 vehicles, but this is the first deployment, about 20 vehicles, and they are putting into place what's called on-route charging. So instead of all the vehicles parking in the same place and charging overnight, those vehicles are actually moving along Chicago Avenue and charging when they have the opportunity. So these are very high power chargers, and some of the complexity that appears there is just alignment of the stakeholders with respect to the city, the various utilities, the permitting process. You can imagine the challenges in a city like Chicago to get a project like that put into place. So on the far left here, a key takeaway is the wrong infrastructure will cost time, money, and disrupt your operation. So on the very extreme side, there are cases where someone is ordering an electric vehicle. The vehicle arrives and the infrastructure was not put in place. You have vehicles that you can't charge. That's a very extreme example. There are also examples where the infrastructure costs too much because it was not planned in advance. So spending money on the wrong infrastructure that's not flexible, or the infrastructure that's put in place and it disrupts your operation. So an example of that is conducting construction activities that are disrupting your business operation. The timelines vary significantly. These are illustrative, but one example is if there's existing power infrastructure that needs minor upgrades, a project can be 6 to 9 months. There are also projects that can be 12 to 24 months. So it really depends in terms of the infrastructure you're going to need to support electric vehicles. And then the last piece here, in terms of challenges, you really need expertise in terms of real estate development. One site is not the same as another as it pertains to where infrastructure makes sense. Complex stakeholder management, which we've alluded to already. Commercial construction experience, but also energy and infrastructure experience should be a part of the team that you employ. And deep urban experience and environmental risk management and it being a part of this. When you talk about infrastructure in metro areas, a lot of times there's environmental risk that needs to be managed and mitigated. So a couple of best practices. Number one, planning upfront. So making sure infrastructure is part of the discussion as soon as you start to talk about vehicle electrification. The top right, utility engagement. They're a key stakeholder. In some areas, utilities have the ability to own and operate infrastructure. In some cases, they have incentives. In some cases, you need to figure out how long is it going to take to get the power that you need on site, and the utility is a part of all those different equations. Scale, so identifying a framework for scale and thinking about the future is a best practice as well. And then the final best practice is design, build, delivery. So I won't bore you with construction delivery models, but the traditional method is design, bid, build. That's where there's 100% design. It's put out to bid for the lowest cost, and then it's constructed. You lose a lot of the learning that the different stakeholders can share with each other when you go design, bid, build. When you go design, build, construction is taking place at the same time as design, so you can realize more efficiencies. And we found that can reduce timelines and actually save money as well. In addition to that, a customer only has to manage one firm instead of managing multiple different scopes and firms. Greg, who is joining us on stage, he'll be able to answer more questions on this, but this is actually an implementation example at Mortenson's campus. So we are seeing more and more demand from our employees for us to provide electric vehicle charging. So we're doing a smart charging pilot at Mortenson, and it includes a mobility house operating these chargers remotely so that we're not hitting demand charges, so we're operating more efficiently, and it's something that learning will be able to bring to other customers. The other thing we're doing with the mobility house is joint feasibility studies. One of the insights from the study that I shared, or maybe I didn't share this, is the fact that 90% of fleets have or will go through a feasibility study to figure out if there's a business case to electrify. So that's usually the starting point in terms of electrification. Let's conduct a feasibility study to figure out if it makes sense. And we're jointly doing feasibility studies with the mobility house. In terms of what the portions are for feasibility studies or pre-construction services, there typically is an assessment of the fleet and modeling of that fleet. If it was electric, what might it mean in terms of electricity costs? An analysis of the infrastructure and what infrastructure upgrades may be needed. We'd recommend what charger you should have. And that's typically where the marketplace stops in terms of feasibility studies, but we also add to ours, what is the cost, what's the schedule, what's an implementation plan? The last thing you want to do is stop a feasibility study without the actual plan to implement. So that's something that we actually offer in the marketplace. So in summary, electrification of transportation is coming and coming quickly. We talked about the fact that within 5 years, 50% of fleets will move towards clean transportation, and electric is the transportation of choice. Infrastructure is the biggest barrier. We talked about the fact that there is not enough of it. Implementation can be complex, and it needs to be discussed a lot earlier to avoid some of the pitfalls that can come into play. And with that complex implementation, engaging the right firm and expertise to make sure you have the right infrastructure plan is critical. Thank you very much.